Michigan State University researchers Evangeline Alosilha, Andre Bachman, and Richard Lunt have been named senior members by the National Academy of Inventors. The MSU researchers being honored have found that their research often presents a challenge that provides an opportunity for invention.
All right, my name is Evangeline Alosilha. I go by Vanji, and I'm a professor in the Department of Biosystems and Agricultural Engineering. And I have been at MSU as a faculty since 1993. And I do research on nanotechnology-enabled biosensors. I can explain that later.
Yes. Andre, introduce yourself, please, sir.
I'm Andre Bachman. I'm a professor at Michigan State University, and I'm in the Department of Pediatrics and Human Development. And I'm also the associate chair for research in the department. We are a clinical department with a lot of PhD researchers, though, so it's kind of a unique situation. And my research has been, for the last 23 years, on pediatric cancer primarily, neuroblastoma in particular. And about 5 years now, I've been focusing on rare genetic diseases. We discovered a new disease called Bachmann-Bopp syndrome, and so that's what we've been researching for quite a while now. And found also some drug that works in that particular disease. And so my general area is pharmacology and drug development.
Awesome. Well, and we have invited Vanji and Andre on the program today because they have just been named senior members by the National Academy of Inventors, a pretty prestigious honor, so congratulations to you both.
Thank you.
Thank you.
And Vanji, let me go back to you a little bit about your research that has led to some of your inventions, sort of, and for your passion for doing that. We said, a lot of people do research, but to then even go and invent solutions is pretty cool. Talk a bit more about what you do and your passion for it.
All right, so my passion started way back. I was sitting in a conference with the Department of Homeland Security, or Department of Defense at that time. They were discussing about anthrax possibly becoming a weaponized agent. And they were saying we need a rapid test to inform the public within 15 minutes so that then the public can be saved, for otherwise it would be really bad. I was sitting there and I was like, okay. And I recalled my background. My undergrad is chemistry. I did a master's in soil chemistry and plant physiology, which introduced me to the biology side. Then I came here as a student for my master's and PhD in system science and electrical engineering. And I thought, I think I can find a solution for that. So at that time, biosensor was an emerging field. And so I started studying biosensors, and then came nanotechnology, and I started studying nanotechnology. And I thought I can combine this and address the issue of rapid test. So that's how I started in developing a rapid test. And so the idea really, when you said rapid, you have to do it within a certain period of time where you can save the patient. So that's how I started the technology. And then 9/11 came, then anthrax was released, so it became a reality. So then I was connected to the Department of Homeland Security Research Center, and that started my research on rapid tests for anthrax as a bioweapon agent.
And that's among the inventions that is getting
That's
you
correct.
into the academy as a
Right.
senior member, yes.
Right. And then, following that, moving forward, I work on tuberculosis, rapid detection of tuberculosis. And I got I was informed that then through my research that 1.5 million die of tuberculosis a year. So then I thought, how can 1.5 million die of a treatable disease? So then I started looking at the problem, and rapid diagnostics was the main barrier. So I started working on tuberculosis, and I got funding from Kellogg, Kellogg Foundation. And the idea was to translate this and test this among the Mayan communities in Mexico. So I went to the mountain in the Mayan community. And you remember that my rapid test is US based because it's funded by the Department of Homeland Security. So we have the fancy technologies. I got there in the mountains and I noticed like there was hardly any electricity. There was no cold storage. I'm like, my technology is dead on arrival. And so I came back and I was like, we need to rethink this. We really need to save people's lives. It has to be very simple, affordable, accessible. And that just grew my passion when I started looking at the community where at that time there were only 7 million Mayans in the world, and they have very high TB rate incidence. And I thought, if no one would help them, these people will die, will become extinct. So that started my passion for helping the very poor. And so our technologies from here on has to be guided by affordability, accessibility, and simplicity. So that's how it started.
Spartans will. And Andre, how about you? Similar question.
Some overlaps actually that I didn't know. I started out in the plant physiology as well. I got a master's degree first before I went on to do a PhD in more of the cancer biology world. But I think my key moment, or one of my key moments, was in 2001 when I became an assistant professor. At the time, I was at the NCI Designated Cancer Center in Honolulu in Hawaii, and where I was for 20 years before I came to Michigan State. I attended a conference in Paris on pediatric neuroblastoma, which is a pretty fatal cancer. And I got interested in that because my lab neighbor was an MD, had a lot of patients with neuroblastoma, and he did research on that. So I started to get interested and went to the first conference for me in that field. And I'm originally from Switzerland, so typically I'm on time. But I was not on time that time. And there was the big gala dinner, and I ended up coming in late, and there was only one seat left in a big room of maybe 1,000 or more people. And I sat down on that one seat that I could sit down, and it turned out to be a table full of parents that had kids with cancer. And being a basic scientist at the time, PhD, never really seen a patient myself, it was pretty shocking. There you are looking through the microscope every day, looking at cancer cells every day, but it doesn't dawn on you, even though it should, that these cancer cells came from a tumor that killed a child once, right? And so when I heard those really sobering stories from those parents, the one thing that stood out was that they complained. These parents attend basically these conferences because they're hoping to find something for their kids to work, because a lot of times the relapsed patients especially, they do not respond to any of the chemotherapy. And so they go there, but then what they complain about is that every time they talk to researchers or physician scientists, the same answer comes out. Well, this is not going to be ready. This is going to be another 15, 20 years. It's going to be $1 billion, maybe back then $500 million. And so they said, that's not what we're looking for, right? We need something yesterday or today, but not in 20 years. And so that's when, for me, the idea of repurposing drugs came to mind, meaning taking a drug that had already been used somewhere else for some other indication, but maybe it can also work for this new indication. And today, companies do this, and everybody seems to be on that wagon. But back in 2001, really it was not as a popular term. In fact, some people told me I'm risking my career as a young assistant professor if I'm going to go down that route. So I didn't really care, because I really thought that repurposing a drug means you already have all these data, safety data. You can move much faster, right? It might not still be tomorrow, but it will be much faster than if you have to develop a brand new drug. And so that's when I went back to Hawaii after the conference and started to write some small grants. Eventually got an NIH-R1 grant to do more significant work and do the preclinical basis of this, and then ended up going into a clinical trial, which is what brought me to Michigan, actually. Phase 1 clinical trial at Helen DeVos Children's Hospital in Grand Rapids. And so one thing led to another, but and the drug was just FDA approved in 2023. So still took a long time, but there were trials that children already benefited from that drug that I had thought of. So that drug is called DFMO, and it has actually been used in West African sleeping sickness, or trypanosomasis. So big safety profile. It's a very safe drug, and so we have used that. So I had some patents around that, But then later came the Bachmann-Bupp syndrome, which is Bupp is the physician I'm working with at Helen DeVos Children's Hospital. By serendipity, purely, we came across a patient that had a mutation in a gene that I was interested in, called ODC. I worked with that gene for 30-some years, and he had a patient, didn't know anything about the gene. I knew everything about the gene, but never seen a patient before. So the two of us got together as a real physician-scientist team, and long story short, we again were able to repurpose a drug and wrote a patent and got the patent licensed immediately, so it's commercialized already and producing royalties for MSU.
I remember that making some pretty cool big news too when
That's
you guys
right.
teamed up. That was great. And
Yeah.
let me stay with you, Andre, and then we'll ask Vanjie. She's kind of answered it, but why did you originally come to MSU? And is there something about this, maybe you didn't know you were going to invent when you came here or not, but is there something about sort of the ethos at MSU that is conducive to collaboration and entrepreneurship and inventing, more so than maybe another university?
Right. I would say at this point, absolutely that is true. I did not know that, though, when I came. I should be honest, right? I didn't know that that's the case, but today that is definitely true. I have a lot of collaborations, and I've received a lot of help. I'm happy to go into this from MSU T, as well as from Spartan Innovations when we founded the company, and for a different patent, not this one. So absolutely, there's a lot of collaboration and opportunities, and so many core facilities. We have a medicinal chemistry core here in East Lansing that I had an R21 grant once, and we were, doing new designs of molecules through that. And so, I have really enjoyed my time here since 2015. The reason why I did come, though, to MSU was because of that phase 1 clinical trial that was really going on at Helen DeVos Children's Hospital. That physician was also connected to MSU, and one thing led to the other, and that the opportunity as a tenured professor came up here. And so my wife is from Hawaii. I lived there for 20 years, but we were looking for sort of an opportunity to do something different after so many years, and it was a leap of faith, but we really are happy here, and we enjoyed it.
I'm glad to hear that. And Vanjie, do you concur that there's sort of an entrepreneurial ethos here at MSU that allows you to be the inventor you are?
I definitely feel supported, and I've been connected with the MSUT for a long time because of, the biosensors versus a rapid test and so on, and they have been very supportive. So did I choose it? I just came here, right?
Yeah.
Because I came as a student, did my MS, PhD, and then I went back to the Philippines for 2 years, and MSU called me back and
Yes.
said, we want you back. And so that's how I got back. So it's faith, right?
It is.
Kind of
It
like,
is, yeah.
it was not really like I intended, I planned this, but
Yeah.
I thank God for that, right?
Yes,
Because
right.
I'm enjoying it here, and we have fun. I
Right.
have fun.
Yes. Emily, are you? My colleague Emily Lordich is here.
Yes. So, do you when you think about someone coming to you and saying, "Look, I do all this research. I have these ideas. What advice would you give me as far as moving towards commercialization or applying for a patent? What would you tell someone who says, "I have an idea, but I don't know what to do with it"?
So from my experience, the technology pool is a need, right? You really need to know what's needed out there. Just for example, our niche, because there are existing and powerful diagnostic tools, but you have to send the sample to a lab. Mm-hmm. And biosensor has the niche of bringing that diagnostic to the patient, to the bedside, because it's rapid. So now, instead of traditionally, like you say you have a problem, you draw your sample, you go to a lab facility like Asparo, for example, and then you wait for maybe 2, 3 days, 4 days. Whereas in the biosensor world, you can detect it right there. Maybe you wait for a few minutes. So so basically the niche of biosensors, and especially with the incoming of nanotechnologies, that we can design a diagnostic test that is like within a waiting period, so that then clinics can do it, home tests can do it and bridge the time gap. And there are some of my other activities right now. Our research is on drug-resistant infectious diseases, where you need immediate information, at least with the physician, so that then they can provide the correct antibiotics. Because right now, because of the delay in the diagnosis, the physician is forced to give broad-spectrum antibiotics, which is creating drug resistance everywhere. Now, in order to minimize that and control that, the physicians need to know exactly what the disease is, what are the drug-resistant genes, so that they can tailor their treatment accordingly. So speed, especially for septic patients, speed is a major problem. And then to have like septic patients or this kind of patients in cancer patients is really a challenge. So you need a quick information, and that is where the biosensor can play a role.
Andre, do you have other advice for folks that would be interested in going down a similar path as far as scientist turned inventor, or doing a little of both?
Right. Well, it depends on which space you are in, but I guess both of our spaces are probably similar in that sense. If you really want to make a difference and go to the clinic, if you want to do translational research, you really want to see your drug, whether it's a new drug that you found or discovered, or whether it's a repurposed drug. We did both. If you do not file a patent for that, it will get stuck at some point. You will hit the end of the road as an academic, right? Money is only so much in academia. If you really want a company to pick this up, getting FDA approved, ending up in the pharmacy on a shelf, you need a company to help you. Company's not going to help you unless you have a patent. So that's just a fact. I mean, because the companies are for profits, and so they do need that. Now, to me, that's probably the first motivation. So I have heard a lot of people say, well, why would you get all these patents? You want to enrich yourself on your science. You should be a pure scientist, and you shouldn't worry about money. And so I said, well, that's good. But what I just said, if I do not do this, I did all this work, years of preclinical research, and published all those beautiful papers, but it's all not going to do anything in the end, right? If I don't protect my work with some kind of patent that then it can take. If your goal is to get to the patient, to the human patient, if you just want to do basic science and understand, I'm not trying to play that down. It's all very fascinating type of work. But if you are in the business of trying to develop a drug for humans, or maybe even for veterinarians, but for humans, you do have to protect your work in some ways. Otherwise, it's not going to ever really succeed. And just seeing that repurposed drug being FDA approved in December of 2023 is just a perfect example for that.
Yeah, so my experience related to that was I was not interested into like patents or things like that, right? I just want to help the poor. That's my goal. I just want to help the poor. But then somebody came into my lab and like, your goal of helping the poor will never be achieved if your technology stays in your lab. And so it has to go out. And so that's when I started like, oh, okay, this needs to go out. So that's basically what Andrew was saying.
That's really interesting.
I think that's an interesting idea, too, that research isn't something, like you said, that just happens in the lab and stays there, right? It becomes part of people's daily life. It goes out, has to go out into the world. And that this invention, this commercialization is part of that process.
Mm-hmm. And MSU helps you quite a bit, like you said earlier. I mean, I work with Anupam, and he has been really, really helpful in getting, initially you submit an invention disclosure, and you can pretty much submit an invention disclosure on anything that you feel could be interesting, and then maybe they come back and say, oh, this is not so interesting. or but at least submit it and have that date locked in, and then they do their due diligence, and they do their work on it and look at it, and then have interviews with you and find out whether or not they think that there's something in it. They talk to the patent lawyers and so on. And then every now and then something turns into a provisional patent application, and then we move on. And there's so many also grant opportunities. We just recently submitted a TSD-GD grant. Don't know if I'll get it, but it's connected also to a company that is already interested in licensing. This is not the patents. We already have licenses for a new one that's upcoming. They are interested in licensing that, and already now, before we even have the patent, so the companies is already lined up for it, and that's when you get also, I guess, incentives and help from the university to kind of push all this forward.
Well, you led me into my question of what's next. Researchers and inventors like you guys are always, okay, now I need to work on this. What's keeping you up at night these days?
For me, it's the area of drug resistance in infectious diseases, and especially cancer patients or immunocompromised patients. That is an area of my passion too. And then, of course, prevention. So we are looking at the whole spectrum of developing biosensors for, say, for example, for the food supply chain, because that's the beginning of where sometimes bacteria can come into the population or the patient, and then before the patient gets to the hospital, maybe we can prevent it by making our food clean, making our water clean, making our environment clean. So that is do a preventive method by developing biosensors for this kind of supply chains and other environmental issues, so that then you basically protect the patient or protect the people by keeping the bacteria or the infectious disease from getting into the community. So that is my passion.
Well, I sleep pretty well at night, so I don't really, nothing keeps me up at night, but
I love it.
I don't sit there and think, what's my next patent that I could do, right? It sort of just happens.
Yeah,
If you're doing research, there's an interesting result. So usually it's the ones that don't do what you expect them to do, and then you start following up on that and find something new. We have a few projects that have to do with alopecia, with hair loss, not the type of hair loss that men typically have, but a type of hair loss that's called areata, which is spotty kind of hair loss, depending more on the autoimmune responses that people have. And there's a big problem. And so we just by chance kind of came across an idea that I won't reveal now in detail.
Right.
But the patent is going well, and so we're trying to get some additional data for that. But for me, the end point is always the human, right? I want to help humanity in whatever small way it may be. But and working in the rare disease space is always a challenge. I mean, we're talking about clean water, right? We could save so many more lives if we just provide clean water. Mm-hmm. There's thousands, millions of people or children dying every day because of dirty water. But at the same time, there's a space also where you have very rare special type of diseases, and these people deserve attention too. And I mean, even pediatric cancer, I wish there was zero, but it is considered a rare disease by definition of what is a rare disease, below 100,000, I think, or so patients. So it doesn't really matter for me whether it's one patient that I may change the life, or if a million. I mean, it's great if you can change a million patients' life, right? But to me, it's a great satisfaction to see when we treated that very first patient that I referred to initially with Bachmann-Bob syndrome, to see her hair grow back, or to see eyebrows. The parents were ecstatic to get these results. Neurodevelopmentally, she started to improve, not just neurodevelopment, global development really improved in her. It's one patient, but it's one important patient, and so to me that's really the biggest payout at the end of the day. So.
You and Vanjie share that same motivation that of basically helping people. Yeah.
Yeah, and just like what Andrew was saying, one person is worth all the effort, right? So I encourage my students, like, even if you can just save one life, it's worth your life on earth, right? Mm-hmm. So I think that is one person at a time, and if we can do that, we'll make progress.
Michigan State University researchers Evangeline Alo-Silha and Andre Bachman, who along with Richard Lunt have been named senior members by the National Academy of Inventors. There's more at academyofinventors.org. And I'm Russ White. This is MSU Today.